Hello everyone, welcome back. In this video, we'll be learning how we can interface HC-SR04 ultrasonic sonar sensor with Arduino and LCD. So let's get started. HC-SR04, this is an ultrasonic sonar sensor. And what does it do? It triggers a sonar boom, and if there is some object ahead of this sonar boom, then it will get reflected from the object and the sonar sensor will receive it. So with this principle of working, there is a transmitter and there is a receiver. The transmitter creates the sonic boom and it launches the boom through the air at the medium. If there is an object at the orientation of the sonic boom, then it will get reflected and will be received at the receiver. So for that reason, there are 4 pins for ultrasonic sonar sensor. First one is VCC. We need to give 5 volt power at this terminal. We have ground. We need to connect ground of Arduino at this terminal. We have 2 special pin. One is trigger and another is echo. So trigger is basically for creating the pulse or the sonic boom in the air medium, and echo, it basically receives the reflected signal from the object. This is the functionalities of this 4 pin. It operates at 5 volt. The operating current is 15 milliampere. The operating frequency is 40 kHz and the minimum range it can measure is 2 cm or 1 inch, and the maximum range, that is 400 cm or 13 feet. And the accuracy is around 3 mm. It can measure up to 15 degree. So all of this being said, let's go to the programming part. We can divide the programming in 3 steps. First, defining the pin modes. Let's say you have defined the trigger pin as 3, echo pin as 2, and with this definition, you will define trigger pin as output because it will be launching sonic boom at the air medium, and echo pin will be the receiving terminal, that's why it's an input. Then the second step is we need to generate a pulse for transmitting, and in that case, we need to create a pulse using the trigger pin, and we'll have to set it to high for 10 microsecond to generate an ultrasonic pulse at 40 kHz. So that's why at this code blocks, we have first made it low, then high for 10 microseconds, and then again low. For this 10 microsecond highest state, it will generate a 40 kHz ultrasonic pulse. Then if there is any object, the pulse will get reflected and will be received at the echo pin. To calculate the distance, for that we have the third step, calculating distance. We need to find the duration. The duration will be calculated by this statement, that is pulse in echo pin, and we need to put it at high. The speed of sound in the air is approximately 1130 feet per second or 343 meters per second. Using these values, we can calculate the distance both in centimeter or in inches. So the distance will be the duration divided by 2. Why we are dividing by 2? Because the duration it has taken, it is the distance between traveling and getting reflected. So the time covered is basically twice the time between the distance of the object and the transmitter. That is why we are dividing it by 2. And duration divided by 2 divided by 29.1, that's for the centimeter. If you are looking for inches, you need to divide it by 74. And with this course, you can finally get the distance from the ultrasonic sonar sensor. So let's program the project in OQI. We'll first bring in the ultrasonic sonar sensor from here. If you go down, you will find HC-SR04 ultrasonic sonar distance sensor. We'll bring this one. We'll connect the VCC with 5 volt. We will connect the ground with the ground pin. Now let's connect the trigger to pin 3 and echo to pin 2. So you can connect to any digital pin. Trigger, let's give it a color like yellow, and receipt color, let's make it. If you want to see the reading at the LCD display, we can do that also. Let's bring in a LCD display with 16:2 and I2C. The connection is pretty simple. Just connect the ground to ground, connect the VCC to 5 volt, then connect the SDA to A4, SCL to A5. So that's a pretty simple concept of wiring. Now you need to do the programming for this one. We'll do this step by step. Let's first program for ultrasonic sonar sensor, then we'll configure the LCD. To program for ultrasonic sonar sensor, the first step was defining the pin modes. So let's define constant integer. We have connected the trigger pin to pin number 3. So let's make it 3. And echo pin, we have connected the echo pin to pin number 2. So let's do that too. Now within the void setup, you need to define the pin mode. Pin trigger pin is our output pin, and pin mode echo is our input pin. So that's the first step. In the second step, we need to create a pulse for 10 microseconds. So let's do that, creating 10 microsecond pulse. So how to do that? We need to write digital write. After that, using the trigger pin, we need to make it low first. Then we will wait, delay microseconds. For 2 microseconds, we will just wait to make it low. Then again, digital write trigger pin, and we will make it high. We will keep the trigger pin high for 10 microseconds. So that is why we'll wait again for 10 microseconds. After 10 microseconds, we'll make the pin low. Digital write, trigger pin, low. So that will be all for creating 10 microsecond pulse. Now we want to receive the pulse and calculate the duration and distance. Let's say integer duration equal to, we'll use a function named pulseIn from echo, and we'll keep the state high. So it will try to find whether the echo pin is high or not. After that, it will find the duration, and you need to calculate the distance also. Let's say you want to find a distance in centimeter. So how to calculate the distance? The duration we have just calculated. It is for traveling and receive time. We'll divide it by 2. And if you want to find the centimeter distance, we will have to divide it by 29.1. If you are looking for distance in inch, then you can divide it by 74. So these are standard formulas, and I have explained them why we are using these formulas. Now we have calculated the duration and distance for ultrasonic sonar sensor. We need some means to display this value at our internal or external screen. Let's do the configuration for LCD. We'll first bring in include liquid crystal I2C.h. Then we will configure the liquid crystal object, liquid crystal I2C, and we'll give it a name, that is LCD. Then we'll put the address 0x27. The display we are using is 16 column and 2 row. So that's how we create an LCD object. We will initialize the LCD. The process of initializing is lcd.init and then lcd.backlight. We have already discussed all of these steps in previous videos with LCD with I2C. Now if you want to show the values at the LCD screen, you need to first set cursor, lcd.set cursor. Let's say 0.0 value for coordinate. Now lcd.print, we want to print first the distance in centimeter, then again lcd.print. We want to print the value of distance centimeter. I'll just put it here. That will be all for printing the centimeter distance at the first line. Let's do the program for second line also. Column 0 and second row. In this we want to print the distance in inch. Let's do this. INCH. Well, I think the distance in centimeter and distance in inch, it will exceed our column limit. Like here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Already 16 digit is covered only for the text. So let's make it shorter. I think it will be enough digit for showing the display. Now after each reading, we want to make a delay so that we can make it stable. Also, we need to clear the display's time. So that's all for the programming. Don't forget to add the libraries at the library manager also. We are using liquid crystal library here, so let's add that at the library manager, liquid crystal I2C. Okay, I think that's all. Let's run the program and see if our program is working or not. So here you can see we are getting a distance in centimeter and both in inch. To change or observe the value, let's make it 400 centimeter, and we are seeing that the distance in centimeter is 401 and in inch it's 15. So as we are not using the actual decimal values, so that's why it's giving us some 1 centimeter error. That's not a problem, I think. Let's reduce it to 2 centimeter. It's getting 2 and in inch 0. Let's make it something 192. Okay. I think it's working well. So that's all for this video. I hope you got the idea how to interface an LCD and ultrasonic sonar sensor with Arduino. Thanks a lot. I'll see you all in the next video.